Hello, am I audible? Uh, Someone please confirm.
Yeah. Harsh, you're audible.
Okay.
Harsh, you can try presenting your screen once and check your video too once.
Is it okay?
Yeah, it's okay. Just press present once and let's have a
Yeah,
look.
yeah.
Yeah, it's perfect. Like I can see everything.
Okay now?
Yeah, perfect.
Hello, am I audible?
Yeah,
Hello.
you
Yeah,
are.
Abhilash, you're audible.
Okay, okay, fine.
Yeah.
Uh, shall I start or wait for more participants to join?
We can wait for 2-3 more minutes and you can start off at 5-3 or something.
Okay. Yeah, so I'm starting. Yeah, so hello everyone. I'm Harshvardhan Daga, one of the coordinators at Programming Club IITM. I welcome you all to the session number 3 for the summer programming camp. The topic for today is time complexity and sortings, and I and Abhilash will be taking this session. So, without waste of a second, let's start. So, topic is time complexity. Uh, here basically to clear two misconceptions about time complexity. First one is that time complexity gives the exact measurement of the time, and second one, time complexity is a very complex uh, and not a very fundamental topic that generally confuses CP solvers, and uh, people are generally confused regarding this topic. So I'm here to clear your confusion. Okay, so let's discuss the content table for today's session. Uh, Today I'll be covering three topics broadly, which are firstly the big O notation. Second one is the best case and worst case, which is a very important topic that's knowledge of this topic is required to implement in almost every question. And third one is common time complexities. Okay, so yeah, we'll begin with the introduction of this topic. Okay, time complexity. Time complexity is a very fundamental concept in competitive programming that measures the efficiency of the algorithm. I told you in the beginning only, time complexity does not measure the time, and it never tells you the exact time for which your code will run. Okay. And in C++, understanding time complexity is very crucial to write an efficient code. Why? Why understanding time complexity is important? Let us see. It helps us evaluate performances of our program and optimize them for better speed and memory usage. In programming contests, and while you solve any problem, your program or your code needs to finish within a certain time limit that is provided by the question setter. Okay, so you should make sure that your code runs in that particular time. How will you know that your code will finish before this time? The idea of this, the idea of this measurement of time is given by time complexity. It never gives us the exact time for which our code will run. It just gives us an approximate measure through which we can estimate that how long will our code run or will it pass under the given constraints. An approximate data which you can remember is 10 power 7 to 10 power 8 iterations which are required, which are executed in a second. In this presentation, upcoming slides, we will explore the basics of time complexity in C++. One important note. I mentioned earlier, time complexity of an algorithm is not equal to the actual time required to execute a particular code, but it measures the number of times a particular statement executes. Okay, you may get surprising results. Like for executing n equals to 10 operations, you may get 0.5 millisecond time. Whereas for n equals to 10 power 4 operations, you may get 0.2 milliseconds time. Why this difference is there? Firstly, it depends on machine to machine and compiler to compiler. Like if you run an O of n solution, which I will brief you about in the upcoming slide, on code forces, it may take 100 milliseconds. Whereas if you run the same solution on another platform like CodeChef or any other compiler or any other IDE, you may get different time than 100 milliseconds. That may not be same. Okay. Yeah. So it also depends on another factor, which is network load, but that doesn't affect much. So you just have to keep in mind that time depends on machine to machine and compiler to compiler. That's it. Take your phones out and scan this QR code for attendance. I'll wait for 2 to 3 minutes. I guess there is an issue with the QR code. Once you click the skip advertisement, you will be redirected to the attendance form and you can mark your attendance there. Is it okay? Can anyone confirm once?
Yes, Abhishek, works.
Okay. I'll repeat once that attendance QR is working. You have to just click on skip advertisement and it will take you to the attendance form. It will be shared once more at the end of the session. So I'll resume. Yeah. So let us start first topic, which is the big O notation. This is a very trivial and a bit important topic, which is used to approximate and calculate time complexity. So let's see. Okay. So as I mentioned earlier, that the concept of time complexity is not the time required for execution of a code. That I am repeating again and again because it's a very big misconception that needs to be kept in mind. It basically calculates the number of operations. So we need a method, or we should devise a method which helps us to calculate the number of operations in terms of input size n. Okay. So that method to calculate that big O notation helps us. The big O notation expresses the worst case time complexity as a function of input size n when n gets arbitrarily large. Why only we deal with worst case time complexity, that we'll learn in upcoming slides. You have to keep this in mind till that time. Okay. Basically, time complexity is the upper bound for the number of steps of an algorithm that it is performing as a function of input size n. In big O notation, we denote the time complexity as big O inside the bracket function of n, in which we have to keep two things in mind. Firstly, we ignore the additive constants, and secondly, we ignore constant multiples. And third technique is we ignore the lower order terms, that is by approximating. So you should have a look at this graph, and it is very important to take note of all of these functions, since these are the common time complexities which we usually deal with when we are solving a CP question. So have a look at this. Yeah. So I'll continue this. Yeah. So this is the key slide for which I was waiting for. Welcome all the engineers. We are here to teach you the basic principle of engineering, that is approximation. Now, you need to use the technique of approximation in question and enjoy solving them. All right. You have to keep two things in mind. First, you have to remove additive constant and constant multipliers. And second thing is you need to use the technique of approximation. For that is, for arbitrarily large n, you have to take only the higher order terms and neglect the lower order terms. One of the approximation technique that is used by engineers commonly is given as pi, which can be approximated as 3, and e, which also can be approximated as 3. Okay. Yeah. So the key thing to learn is by practicing. So I will give you 4 to 5 minutes to attempt these 5 questions and represent these functions as in the terms of big O notation. And we'll discuss the answers of these questions after 5 minutes. By the time, if you have any doubt, you can write in the comments. I'll be reading that, and you can also solve these questions. Just a second. I would request not to write answers in the chat soon, so that everyone get a fair chance to try. Once everyone has attempted, shall I start? You can write yes or no in the chat box, or you need more time to attempt. Okay, so I'll start discussing the answers. Yeah, so here are the answers for the 5 parts. I'll discuss all the parts one by one. First, f of n is equals to 3. Observe that there is no power of n, uh, no, there is no term of n which has a power which is a natural number. So when n, irrespective of n goes arbitrarily large, or n remains at a smaller value, the the if we represent it in terms of Pego notation, it will be a constant only. Hence, it will be O of 1, since 3 is a constant. Going to the second part, f of n equals to 2n plus 5. So first thing, you have to ignore the constant multiple, and second, the additive constant. Okay, ignoring the additive constant, you get as 2n, and when you ignore the constant multiple, you will get as n. So we can write this in terms of O of n notation as O of n. Moving on to the third example. This example requires decent knowledge of graph, which I showed on the previous slide. Since n is getting arbitrarily large, so n will become much greater than log of n, as shown in the graph. I'll take you back to the graph. See here, as for arbitrarily large n's, the slope of this graph becomes almost 0, and this has a constant slope. So for large n's, O of n will become much greater than log of n. So we can ignore that term with respect to n. Hence, it becomes O of n. Yeah. Moving on to question. Fourth question. We can split it in two terms: n square by 2 and n by 2. For arbitrarily large n, you can observe that parabolic function becomes much greater than this linear function. So we can ignore this, and it becomes n square by 2. And ignoring the constant multiples, we get O of n square. Okay, I guess till now this is fine. If anyone can confirm. Uh, I'll come to this once again. Yeah, we'll discuss the last part and I'll recap the big O notation once. Okay, so last part is a bit tricky part. Since f is represented as a function of two variables, so you cannot ignore any one of them. If n and m are comparable, then the the big O notation form becomes O of n or O of m, since the both of them are comparable. If one of them becomes arbitrarily large, that is, if n becomes much greater than m, then you can represent it as O of n form of big O notation. Or if m becomes arbitrarily large, you can represent it as O of m in the form of big O notation. So I'll recap what big O notation is. Yeah. So time complexity, for calculating time complexity, we need to calculate the number of operations. How will we calculate the number of operations for a generalized input value? That is given to us by big O notation. Big O notation uses the worst case, and it helps us to calculate the time complexity in terms of input size n in the worst case. Yeah, that's it. I hope this is clear. Yeah. So we'll move to our second topic, best case and worst case. Believe me, this is the most important subtopic which I will cover today. And knowledge of this will help you write your algorithms and code smoothly and help you pass your question. You must have observed this term time limit exceeded in some of the questions. By the end of this lecture, you will be able to figure out where you are going wrong, and you'll have a decent knowledge of time complexity. Yeah, best case and worst case. Firstly, we'll talk about what best case is. The best case refers to the most ideal case in an algorithm. Best case is defined in terms of time. That is, minimum amount of time is required for an algorithm to complete its execution. Minimum amount of time is required, which implies that minimum number of operations or minimum number of iterations are required to perform a particular operation or code. It represents the case when input data is already set in such a format that you have to perform least number of operations or least amount of time is required to execute that particular given code. However, in competitive programming, best case complexity is typically not considered because it does not provide us the complete idea and understanding of the algorithm. So how can we take the complete idea and understanding and feel of the algorithm so that we can write our code smoothly? Yeah. So worst case, this guy helps us to write our algorithms perfectly, even though its name is worst case. Okay, so we need to devise an algorithm which works well in the worst case. What is meant by worst case? Uh, by worst case, we mean that input data is set in such a form that we need to perform the maximum number of operations, which implies that maximum amount of time will be taken to complete to run the following code. It provides us an upper bound for the performance of our algorithm and allows us to ensure that our solution is efficient and will run for wide range of inputs. Since our code is working for the worst case, the case which comes between the best case and worst case will are already being covered, since worst case is since the upper bound of the worst case is in our limit. So all the cases which lie between these two will be covered smoothly by our algorithm. So here are two questions that I will discuss, and I'll give you 2 to 3 minutes to attempt. And I would request you not to write answer in the chat box and try these ones. You have to represent these codes in terms of big O notation. You can also write your doubts, and I'll answer them by the time you are solving these questions. If you have any doubt, you can write in the chat box. We don't use notations such as big theta and small o and all, because big O notations gives us the perfect approximation strategy that would allow us to approximate that our algorithm can work in the certain input cases. I guess this much time is sufficient to attempt these two problems. So I'll start discussing. Uh, in the first question, 4 basic operations are performed. What I mean by basic operation is that the operation is without any iteration and is counted uh, as O of as being executed in order of unit time. So 4 basic operations are executed in the first question. So total number of operations will be 4, and since it's a constant number, so the time complexity of this will be O of 1. In the second question, observe that this is a for loop. One operation is being performed there, another is being performed here, and n operations are being performed in this for loop. And the code will be a linear value, constant value only. So it will be a linear function of n. Okay, so we can write this as O of n. Yeah, here's the solution. Note that all operations are basic, and since finite number of operations are performed, as I said, the time complexity will be of 1 and total number of operations performed are 4. Okay, so you can have a look at that. Look at this. So two operations are being performed in the for loop, and here also some operations are being performed. So finally, if you will calculate, it will come out to be a linear function of n. So we can write this as O of n. Yeah. So now I'll be uh, sharing with you a QR code, and you should scan it and answer in the polls on the Slido platform. So keep your phones ready, and I'll give you a minute or so. By the time you can ask your doubts also in the chat, I would encourage active participation in the session. Do you have any doubts? You can write no if you don't have any doubts. I guess everyone's fine with this. So I'll be sharing QR code now. Scan it to answer the upcoming poll question. Yeah. Sorry. Yeah. So I launched the poll for the first question, and I'll show you the first question and give you 2 to 3 minutes to attempt this question. I'll show you the question now. Yeah. So this is the question. I will keep this on screen for 2 to 3 minutes. You can ask your doubts here also, and people those who don't have access for these chats, you can ask your doubts on Slido. Uh, I would encourage everyone to ask their doubts and uh, actively participate in the session so that you can learn a lot from others' doubts as well. Don't be shy. It's okay to have doubts in these topics because these are a bit new for you all. So you can ask your doubts and on Slido as well as here. Okay, so I'll show you the results and all. Yeah, so I guess this is the correct answer only. Yeah, so let's discuss the solution. Okay. Uh, firstly, I'll ask you to answer two more questions. Then we'll discuss all the questions together. Is it okay for you, or shall I discuss the this question once first? You can comment. Shall I discuss all three questions together or after this? Okay, so I'll discuss all the three questions together. You can mark your answer. Okay, yeah. So Second poll is coming up for you, and I'll show you the question also. Yeah, this is the second question for poll, or the fourth question. I'll give you 2 minutes to answer, 2 to 3 minutes. Uh, by the time, if you have any doubt in the first question, you can write in the chats, or you can ask on Slido. Okay, so I'll end this poll and discuss two questions, and we'll then move to third question. This one got a bit less percentage of correct answer. Yeah, O of n square is the correct answer. I'll end the poll here. Okay, so we'll discuss these two questions first. Okay, first question. The first question is a nested for loops. Let me introduce you to nested for loops, how a nested for loop works. Basically, it works like a normal for loop, which has one for loop, another inside one. In for loop, you know that the variable inside the argument of the for is incremented one by one, or according what it's mentioned there. So the operation inside the curly braces is executed. You have to consider that operation as another for loop, and in that for loop the variable is incremented and operations are executed. So firstly, I will be int I is initialized to 0, I is checked as less than n, it is okay. Then this code executes where j is set to 0, j is checked as less than m, then this code executes. Then j is incremented as 1, j is less than, if j is less than m, this code executes, and this code, inner code, runs m times when I is 1. Then when I is 0, sorry, my bad. When I is incremented as 1, then this code again runs m times. So the total number of times this total number of iterations we can represent as a function of n and m as m plus m plus m plus m n times. So it will become n into m. So exact number of operations will be n into m, and hence it will be its time complexity. And there is no neglection, since there is no constant multiple and all. You can ignore that code and all. Moving to the second question, which is the fourth part of our problem. Yeah, here what happens is, when I is set to 0, I is checked, it is less than n. Then we go into the inside part of the curly braces. Here j is 0 and j is checked as less than n, and j is incremented here by 2. So how many times the inner loop executes, we have to calculate that, and the number of times the inner loop executes, same will be the outer loop. Hence the time complexity will be the square of the time complexity of this inner loop. So let us once calculate how many times this inner loop executes. You see that when n is, for example, 2, when j is set to 0, j is checked less than 2, the code executes, then j is incremented by 2 and j becomes 2. So this condition fails and this code runs only one time. And when n is 1, this code also runs one time. So we can write as greatest integer of n by 2, if, or we can write as a floor of n by 2. That is basically n plus 1 by 2. You can write greatest integer of n plus 1 by 2. So time complexity of this will be O of n, and hence the time complexity of the code will be O of n square. So I will show. Is it okay for everyone, or there's any doubt? You have to consider operational statements as well as cin statements, and that doesn't matter because they are counted as a constant multiples, so you can basically ignore them. So it doesn't, basically the game is of the input size n which you have to manipulate. Is it okay? I feel like I should move. Okay, so I'll show you the QR code for the fifth question. You can scan and answer in the poll. Once you have scanned, I'll show you the question. I would request you not to mark the answer before showing the question. Okay. So this is the fifth question. I'll wait for 2 minutes. By the time you can write your doubts and be active in chats and clear each other's doubts so that you can learn from each other. Uh, is there any screen issue? I hope it's fine.
Yeah, Harsh, it's fine.
Okay. Okay, so I'll end the poll now. The correct answer is O of n square. Let's discuss this question. Yeah, so this is a very standard question which you may encounter or which you will encounter in upcoming sessions. So yeah, so let's see. When I is 0, I is less than and I is checked less than n, and the the inner loop runs from j equals to I, that is j equals to 0, till j is less than n and j is incremented by 1. So the inner loop runs n times when I is set to 0. When I is incremented by 1, I is if I is less than 1, we go inside the curly braces. J starts from 1 and j goes till n and j is incremented by 1 and the inner code executes. So when I is set to 1, the code executes n minus 1 times, and then I is set to 2, j starts from 2 and j goes till n minus 1 incremented by 1. So this time the loop runs n minus 2 times. So the total number of times this loop runs is n plus n minus 1 plus n minus 2 till 1. So you know this sum is n into n plus 1 by 2, and we have calculated in the previous question when f of n is n into n plus 1 by 2, or it is n into n minus 1 by 2, the time complexity of the code is n square. So here are the answer for these three questions. Okay. Yeah. So have a look at this picture. You can consider this person as your program and the track on which it is running as the mode on which the program goes, log n or O of 1, O of n or n square. The difficulty it faces with respect to time complexity is same expressed by the person. So you can have a look at this. Okay, so we'll move forward to the third topic for our session, and this is the last topic: common time complexities. We'll have a look at time complexities of some famous or oftenly used functions. So yeah, yeah, mathematical formula that just calculate an answer, just like subtraction or addition. The time complexity of those statements are considered to be O of 1. Binary search, about this topic you'll learn in detail in upcoming session, and I'll brief you about this today also. For finding an element in the array, the time complexity is O of log of n. For finding prime factorization of an integer or checking primality or compositeness of an integer, O of square root of n is the time complexity, and you will encounter this soon, and you won't even recognize that you have been given this code. So stay tuned for this question. And reading in n items in terms of input will be O of n, like you have an array and you have to input n elements from the array. Time complexity will be O of n. Iterating through an array or list of n elements, it is also O of n. It's very obvious since you are taking the iterator from 0th index to n minus 1 index. So it is n O of n. And sorting, which you will learn in detail in this session only, time complexity is usually O of n log n, which mostly CP solvers use. Okay. Iterating through all subsets of size k of the input elements is O of n power k. And for example, iterating through all triplets is O of n cube. You can see this as nck, where n factorial upon k factorial, n minus k factorial, and k factorial is considered to be a constant for small values of k, and this term is approximated as n power k, n factorial upon n minus k factorial. Iterating through all subsets is 2 power n, since the number of subsets are 2 power n, total number of subsets. and iterating through all permutation is O of n factorial, since uh, if the numbers are distinct, then the number of permutations you can make are O of n factorial. Yeah. So let's have a quick look at the application of time complexity, where we see an example where we need to find a particular number in array. Okay. So have a look at two cases. In the first case, you are doing linear search. What is meant by linear search is that it's an algorithm which is used to find an element in the array when you are iterating from first index till the end. In the worst case, if the element is present at the last index. So its time complexity will be O of n, since you are going from the first index and reaching till the last index. Because in the worst case, with which the time complexity deals, and this is our basic idea. So you end up doing n iterations if the element is found at the last index or if it's not present. So its time complexity is O of n. Now you will be surprised to see another method, which I won't be explaining in detail today, as it will be taken up in the upcoming sessions, with time complexity of log of n. When the array is sorted, we prefer binary search. Here is the code for binary search. This algorithms, I'll give you a rough idea, works by dividing array into two parts, a sorted array, and considering the left part or the right part, depending on lesser or more, comparing the values of the two elements with the middle elements. You'll be taught this in detail in upcoming sessions, so I won't be covering this today. Yeah. So let's come to the main part, which is the summary of our session. What algorithm should we prefer when we are given an input size? This is the main thing, since we need to make our question pass within the certain time limit and don't get the time limit exceeded tag. So here is the detail for these input values. When input is less than 100, you can use O of n power 4. We generally don't prefer these type of uh, not I won't say prefer, we don't get these type of algorithms in questions. We get mostly O of n cube or O of n square algorithms, which you can use when size is less than 400. So that number of operations performed are around 10 power 7 to 10 power 8, and time taken is around 1000 milliseconds. Yeah. When the input size is less than 2000, you can use O of n square log n. When it's less than 10 power 4, you can use O of n square. When it's less than 10 power 6, you can use O of n log n. And when it's less than 10 power 8, you can use O of n. Uh, I would suggest that you should be careful with this, since if the input conditions are very tight and strict, then you may get a time limit exceeded. So uh, beware of this. Better to use O of log n if you are finding a method. Yeah, so here is a bonus question for all of you. I'll give you 3 minutes to try, and I would suggest not to write the answer in the comment section, and I'll discuss it. By the time you can ask doubt in chat box and we'll answer them. Is there any doubt? I'll see once. I guess most of the doubts are cleared by now. So yeah, we'll move on to the question only. Guys, you should be active in the chat if you have any doubt or answer others' doubt. That would clear your concepts only. So I would urge you to have an active participation in the session. I'll wait for a minute or so and then I'll discuss this question. Okay, so I'll discuss the solution of this question. The answer to this question is O of n log n. Okay. Yeah. So have a look at this code. When I is 1, I is checked less than equals to n. Int j is equals to I. J is equals to 1. J is less than equals to n, and j is incremented by I. This loop executes n times since j is 1 and j is incremented by 1, which is I. When the inner for loop executes completely, we move I is incremented and I becomes 2. So j is initialized to 1, j is checked less than equals to n, and now the incrementation of j is done by 2 here. So number of times this loop runs is n plus 1 upon 2 and greatest integer of this whole term. Okay, so you have to be careful with these terms. When I is incremented again and I becomes 3, then the inner loop is executed n plus 2 by 3. I hope that this won't be clear now. Just now you have to think a bit. So you have to think on this a little bit, and I'll give you time for this. Yeah. So the number of times the iterations is performed or the inner code is run is n plus n by 2 plus n by 3 plus n by 4 plus till n by n. Now, many of you will have a doubt like how this term came. I'll brief you about this. Once it is clear that the inner loop runs n plus 1 upon 2 greatest integer of this whole part, then I is set to 2. Then you can approximate this as n greatest integer function of n by 2. Since n is very large, you can ignore 1 with respect to n. And then greatest integer of n by 2 is less than n by 2. So you can approximate them as n by 2. Similarly, you can approximate this as n by 3 and this as n by the upcoming one as n by 4 and till this. Now from basic integration, you know that 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 till 1 by n can be written as a summation of 1 by x dx, which is ln n. So the final answer will be n times log of n. References with which you can refer after this session also is Geeks for Geeks and usako.guide, and you can also refer to you can go through the slides once. For better understanding, you can read these. You can go through these links also. You can take out your phone and mark your attendance now, and I would hand over to Abhilash. Don't worry, we'll also be sharing the attendance link on Slido platform, so you can go there and ask. You can go ask doubts and mark your attendance too. By the time, if you have any doubts, you can ask. Yeah. The answer to that question was n log n. It's correct. Abhilash, are you there?
Yeah. Just
Yeah,
let them
so
scan it. I'm waiting for them.
Yeah. Yeah, I guess sufficient time has been given for this. You can also go on Slido and check out there. You have the attendance link there also. I'll stop sharing now.
Hello, am I audible and visible? Hello,
Yeah, you're audible.
and is my screen getting shared properly?
Yeah, it's there.
Okay, okay, fine. Yes, yes. Hello once again to a new session on sorting. Hope you had a great time learning time complexity with Harsh. And the topic which you are learning sorting is kind of very important because at least one question comes in contest now and then. So, and we have some time constraint too. So I hope that you guys follow me line by line. Okay, so what is sorting? What do you understand by the English word sorting? We generally use it like sort means arrange something in some logical order. Uh, Remember that I'm saying that in a logical order, not necessarily in ascending, descending. We'll say it in later. So, like, what's the need to sort some? Let's consider array or a vector. What's the need to sort it? Like in suppose in a question you are asked to find the fifth minimum or fifth maximum element. How will you do it? It's actually tough, right? So what we will do is there are a few different methods of sorting which we will use. Here I have listed a few of them, but as you learned in the previous method that bubble sort, insertion sort, and selection sort methods give time complexity of O of n square, which are not that great. Instead, we have another method called merge sort, which gives us a time complexity of O of n log n. And as you know, O of n log n is much better than O of n square. So we won't study these first three methods in this session. We'll study the last two, merge sort and the custom sorting operator. Okay. So let's start with the merge sort. What does merge sort say? Suppose you have an array like it is shown in the figure. There are a few elements. What does merge sort do is it splits it in, it goes on splitting it until and unless it becomes one element. Then it sorted in ascending order and then rearranges the array again. So the time complexity used by this method is of O of n log n. Okay. This is not that important. We'll look in the inbuilt library functions. Just a minute. Okay. So here's the most important and like exciting part. You guys might have like felt that is there some kind of inbuilt function to do it in arrange the array in ascending order or something. So there is. So if you are given an array, just use this function sort r comma r plus n. It will completely sort the array in ascending order. Now, what if I don't want to sort the complete array? What I can do is, like suppose I want to sort it from eighth element to bth element. So we'll use the function sort r plus a comma r plus b. So it will sort the all the elements from a plus one element to b plus one element. Similarly, like suppose we have a vector is given. So how will sort it? So it's not that we will write n or a or b. What we can do is sort vec dot begin means from where the vector starts to vec comma vec dot end till the vector ends. So it will completely sort the array in ascending order. Guys, note that I am always saying that this function sorts it in ascending order. I have never said that it will you can just change it, or it will somehow you can do it in a descending order. We'll see it later, but for now just remember that it does in ascending order. Let's look at on the code that how it works. A theoretical part is okay, but let's work on the code. Just a second. Okay. Hello, I think I'm not visible. Can someone please confirm?
You're visible, Abhilash.
Okay, fine, completely fine. So look at this code now. This is what basically you have learned till like session 2 or 3. We have declared variables in this first 2 lines, taken an input, declared an array on 6th line, and on the 7th line we have taken the input. As far as now, you have learned all these things. Line number 11, 12, 13, we are just printing out the array which we have taken it. As you can see on the line number 10, our array before sorting was, and line 11, number 11, 12, 13, then prints out. Then line number 16 is most important. What we have learned theoretically is a sort r comma r plus n, which will sort out the array. Now just look at the output. We have taken these elements as inputs: 12, 9, 37, 86, 2, 17, 5. Our array before sorting was this, and after I use this function sort on line number 16, see what the sorted array gets in. It gets sorted in an increasing order, that is ascending order. That scheme, that 18, line number 18, 19, 20 just prints it in the ascending order. That's it. And the main thing about this is the best method to sort it, and the time complexity for this is just O of n log n. In the previous lecture, you saw that O of n log n is much better than O of n square. And remember that I told that there are few methods which take O of n square. So you guys just stick to this method, that just use an inbuilt library function so that you can get the minimum time complexity. Okay, so here we are with our first Slido question. Guys, get ready. Oh, so there is one doubt. What is STL? So STL is standard template library, where a few basic functions are already inbuilt, which are directly ready to use. So some of the functions are like sort, GCD, absolute value. Okay. I think that was sufficient time for that easy question. But still, what I can notice is that many people made a mistake. Many people have marked option number 3, that is vector.begin, vector.end. So I knew that many people would make a mistake here. Guys, note that whenever we are going to sort a vector, we have to use its name and just not write it vector. You can write everywhere that vector.end, vector.end. You have to write the name of the vector. And as you can see in the question, the name of the vector is XYZ. So you have to start with sort xyz dot begin comma xyz dot end. Does anyone have still any doubts? I think it's fine. If you have any, just put it in the chat. I or other moderators will reply to it. Okay, so we'll continue forward. Now here comes the most important part of the sorting topic, that is custom sorting operators. What does the word custom means? Generally, it means that we can change it according to our own needs. Now, just remember that each and every time I was saying that that function will sort the array or vector in ascending order. Now, what if I need to do it in descending order? Can I do it? Actually, the answer is no. Inbuilt function won't, you won't be able to do with that inbuilt function. So you need to make something called custom sorting operator. Now try to remember that while we were trying to sort it, what we used to write is sort vector dot begin comma vector dot end, and that's it, simple. But now what we'll do is we'll introduce the third parameter. We'll write vector dot begin comma vector dot end comma something else, and what that something else is I will show you. Now the main thing is, like, suppose you have a pair of numbers. I have given here two pairs, 6,8 and 1,9. Now if I want to sort these numbers, how am I going to sort it? If I use a sort function, what will be the output? Will the sorted array be 6,8 1,9 or 1,9 6,8? Because you can see that the first elements in the first elements 1,9, that is 1, is smaller, so maybe it could come first. And but if you see the second elements, 8 is smaller, so 6,8 1,9 can be the answer. So what can be the answer if you use the sort function? We'll see soon. Okay, so now is the implementation of code. So you guys just be with me line to line. If you guys don't understand even a single line or word, please write it in the chat box. I will try to clarify it. Just a second. Okay, so I don't know if you are like familiar with pairs or not, but we'll try to understand with the help of this code only. Like suppose you have two arrays, array one and array two. Now, like I asked you in the previous slide, that what will come first, 6,8 or 1,9? Those were the pairs. So we have to just make pairs out of these arrays. How are we going to make it? We'll use on the, see, basically line number 6, 7, 8 and 9, we're just declaring arrays. And okay, so line number 6, what it says is we are making a vector of pairs of integers. Try to note it. We are making a vector of pair of integers. So we have two arrays, array 1 and array 2. We'll be making pair of those elements. So how are we going to make it? We'll see it on line number 11 and 12. Line number 11 and 12, just see remember guys, my vector name is not vector, my vector name is vect. So what does line number 12 says? Vect dot pushback make pair is a inbuilt function. So what I will do is make pairs of add1 of I and add2 of I. That is 10 and 30 will become pair, 20 and 60 will become pair, 20 and 10 will become pair. Hope you guys understand that. And it will get stored in the vector name vect. Okay. Now, what did I just say was line number 14, 15, 16 and 17. As you can see, when these lines execute, we'll get those pairs which we just formed. Like I told that 10, 10, 30, 20, 60, 20, 10 will get paired up. So as you can see that these are the pairs. Now our main question was, what if we just use the sort function to these pairs? What will happen? So we'll just look it now. On line number 20, I just used those that sort function which was inbuilt, and line number after we don't know what exactly was, so we needed line number 21 to 26 to print it out. Now, as you can see in the output, just observe it clearly that all the first elements are arranged in ascending order, and second elements are randomly. I hope you guys can see it. These all are in ascending order, first elements, and all the second elements are in random order. But here comes one problem. What if I don't want 20, 10, 20, 60 like this? I want 20, 60 to be above 20, 10. Can I do it? Just try to think. See, I hope you understand that the first elements are in ascending order and second elements are randomly distributed, or what? When you use just this sort function without the third parameter, it by default arranges first elements in ascending and second element as well as in ascending order. What now you'll see that these are not ascending. Ascending by which means if the first elements are same, then the second element which has lower value will get the upper priority. It will be at top. So you can see that 20, 10 is above 20, 60. Okay, so this is what the sort function will do. But our main question should be, what if I need 20, 60 above 20, 10, or 40, 50 above 40, 2? Can I do that? Yes, surely you can do that. Just we'll see it soon. That's what I was saying. Look at the output and everything. As you can see that the pair 20, 10 is kept about 20, 60, and 40, 2 is kept about 40, 50. That's what I was saying. I don't think I need to read this again all. Now this is a bit lengthy code, and I hope you guys follow me line by line. Just a second. Okay. First, what we'll do is first we'll complete the right side part of the code, and then we'll complete the left side part. Because once you understand right side, you will gain some confidence. We'll again do the same thing. We have two arrays, arr and arr1, with some certain elements. What we'll do is again make pairs of those elements. We'll again name the vector as vect. What I have done is I have made a vector of pair of integers and named it as vect. So the line number 31 to 33, just make pairs of those elements, arr I, arr I plus arr1 of I. So 1040, 1060, 520, 550 will get paired up. Okay, just I'll show you how. So the vector before sort operation, what I was telling is 1040, 1060, 520. Like this, they will get paired up. I hope you get it. Now we'll use the sort function. Wait, I'll tell you how. I hope till now these were just printing of line number 35 to 39. That's what I showed you now. That how the vectors paired up. Now we'll go on line number 41. What this line number 41 says, clearly see that. What we should study now is sort vec dot begin and sort vec dot end. Just that's it. But now here comes the third parameters. I have written it sort one. I'll tell you how. Now what this third parameter does is it's very important. Let's look at it. So like I have made one function called, I have made two different functions, sort one and sort two. And what will they do is they will return the Boolean values. As you have read, as you have learned in the previous sessions, that what does Boolean do is Boolean returns either true or false. Okay. What the first we'll just see sort one as of now, and we'll then do sort one, sort two. So now just concentrate on sort one, as this is like the most important part of the course. So follow me very carefully. What does sort one take? Sort one take in two pairs of integers. Try to understand two pairs, because we have to compare two different pairs, which is going to come first and which is going to come second. So what is its input? It will take two different parameters, a and b. two pair of integers. Now, if a dot first is not equal to b dot first, which means what does this first and everything I'll explain. If a dot first, which means the first element of the first pair is not equal to the first element of the second pair, that is b dot first. If this is the case, then return a dot first, that is the first element of first pair is less than first element of second pair. Return this. Now it, as you know, we are writing a boolean, so it will just output the value as true or false. If it is true, then what we can expect is a will be kept above b. But what if it returns the value of false, then b will be kept above a. I hope you guys are understanding. I'll try to explain this part again so that sort to function can be easily done. If a dot first, that is the first element of the first pair, is not equal to the first element of the second pair, then what do we have to return? What will the compiler return? Either true value or false value, as we are writing the boolean. So if first element of the first pair is lesser than the first element of the second pair, it will return a true value, which means that the first pair should be kept above. If the first element is small, then the first pair should be kept above, as it is a true value. If else, I mean, first elements of the two pairs are not at all common, as we saw in the previous examples. If the first elements are not common, then return a dot second is greater than b dot second. Then we'll check the second values. If the second values, if the second value of the first pair is greater than second value second pair, then return a true value. Then return true, which means that okay, what does the sort function do is correct. Keep a above, b below. Otherwise, just flip it. Otherwise, keep b above and keep a below. Now, whatever we understand, we'll try to understand it via output. Just a minute, I'll explain. Okay, so here is the output. Well, I'll again explain it by switching the slides. I will try to explain it with example. Okay, so we have two different. Let's just take an example: 520 and 550. Okay. Now, what 520 and 550 are the first elements of both the pairs common? Yes, of course, both are 5. So what will it will go in else value? Else, what will it do is return a dot second is greater than b dot second, which means the second value of the first element, that is 20, is greater than the second value of the second pair, that is 50. Is it true? No, it's not. 20 is not greater than 50. So what we'll do is it will just change it. It will flip it. So 50 will be kept above 20. Have a look. 550 is placed above 520. I have to get it. I'll wait for a minute so that you guys can just assimilate it and ask some doubts if you have. Guys, do you have any doubts? Please write it in the chat. I know I'm going pretty fast, but there's some time constraint. Okay, so there are no doubts, I see. We'll try to understand the sort to function now. Now we'll again try to understand it with example. Like you know what's written in the code, we'll try to understand it with the help of an example. Okay, so what does again sort to function? It's a boolean. Again, we are taking in two inputs, two pairs of input. Understand that. We'll follow the same procedure as sort one. If a dot second, that is the second element of the first pair, just keep in mind that a and b are first and second pair, that's it. So if the second, that is this second, if second element of the first pair is not equal to second element of the second pair, then return second element of first pair is less than second element of second pair. Now I'll try to explain this with an example. We'll first otherwise complete the code. Else return that the first element of the first pair is greater than the first element of the second pair. We'll understand with the help of an example. Just look at it. Let's assume any two pairs. We'll take 60 60 and 60 10. Just have a look. We'll take 60 60 and 10 60 as these pairs. Now we'll again understand the code line by line. Now if a dot second, what is our first pair? 10 60. So what is this a dot second? What is the value of a dot second? It is 60. Is 60 not equal to, if it is not equal to b dot second? Are they equal? Are 60 and 60 both equal? Yes. So it won't go in if, it will return a dot first is greater than b dot first. The a dot first is 10 and b dot first is 60. Is 10 greater than 60? No, it will return a false value. So it will flip it. And as you can see, what our output was supposed to be 10 then 60. But as it returned the false value, it will print out 60 and then 10. As it returned the false value, it will flip it. I hope you guys get it. We'll understand with help of another example, as the second values were not same. We'll just then so then in this line number 41, we have just used the sort one function, and then we have printed this values as you see here. These are those values, and we have used the sort two function on just to show you how differently it works. As you can see, there is difference between both the outputs. Here, as you can see, the first elements are in ascending order. You can see that. But just compare, if the first elements of the two pairs are same, that is 10 10, then compare the second elements. What the code does is keeps the greater value above. That's what we are trying to do it, right? In the previous code, what it was doing is keeping both in ascending order. But what we thought of, can we do it in descending? Yes, we did it. 60 is kept above 40. Now, what does the sort two function does? Now look at it very carefully, that the second elements are sorted in ascending order. And what about the first elements? Look at it, 60 and 60. So 60 is kept above 10. I explained you how, which 60 is kept above 10 means the first elements are sorted out in descending order. I hope you all get it. Yeah, I'll explain those lines again, don't worry. There's some doubt. Please explain the last two lines. Last two lines. Okay, let me see which ones. I hope you are saying these two last lines. Just a minute. Yes, I know it's a bit tough, but we'll try to understand sort one again. I know that many of you might be having doubts. We'll try to understand with the help of example again. Let's pick one example. That is, again, we'll do it. Let's do it 520 and 550. We'll use these examples. Now keep in mind your pairs, that is 520 and 550. So we have taken, what is our first pair which we have taken as input? 5 to 20, and what is our next is 5 50. If a dot first, what is a dot first? A dot first is 5. Is it equal to b dot first? Is it not equal to? Another element is 5. So it is not equal to, means the condition does not satisfy. So we'll go in else. Return a dot second is greater than b dot second. What is the second element of the first pair? It is 20, what we took, and is greater than b dot second. It is 50. So 20 is greater than second. 20 is greater than 50? Obviously no. So it will return a false value. So what the sort function will do? 20, it will, as it returned the false value, what it was going to sort, it will flip it. So as you can see here, it kept 50 above 20. What it was going to be? 20. What expression we saw was 20 greater than 50. It returned a false value. Okay. So it just flipped it. It kept 550 above 520. That's what we were trying to do, right? Now let's take an example where the first two elements are not same, so that we can analyze line number 6 and 7 once again. Let's take example 1060 and 520. Remember once again, our A pair is 1060 and the second pair is 520. So are the first two elements same? That is A dot first is 10 and B dot first is 5. They are not same. So we'll go in if loop. If what does it say? Return A dot first is less than B dot first. What is A dot first? It was 10, right? And what was B dot first? It was 5. So is 10 less than 5? No. So it will return a false value. Correct? So what should be kept above? Try to guess now. And look at it now. 1060, 520. I hope you understand it now. I have written the same thing here. Notice that these elements are sorted out in ascending order and these in ascending order. These in descending order as well as these in descending order. So I have showed you both ways. Actually, all three ways. In the first code, we did it all in ascending order. Second, sort one function ascending, this descending. Here, this descending, this ascending. So, like, try to understand. The main thing is playing with these symbols, these angular ones, greater than, lesser than, not equal to, equal to. Playing with this, we can just sort the pairs according to our own needs. I have to get it. Guys, I'll wait 2 minutes more. If you have any doubts, do it now, because we have another Slido question coming up and which is based on this. So if you have any doubt, just ask me now only. I know it's pretty fast, but there's no time to. Any doubts, please chat. Guys, show some enthusiasm. Okay, we'll proceed. I don't think you have any doubts. We'll proceed with our next question. This is another Slido question, guys. Just a minute. Guys, try to attempt it. And guys, okay, so some have doubts regarding attendance. Guys, go on Slido and mark your attendance if you have still not. And okay, show the code. Just a second. Just a second. Sorry. Guys, be quick. Show participation, man. If the answer is wrong, nothing happens. You will get to learn only. I hope most of you have done. Only 75% of people have marked the answer correctly. I don't know how, guys. Okay, so there's another third question coming up. Try to maximize the correct answers. Be quick, guys. And I know that people who are getting the answers wrong, just don't leave it. You will get the recording soon of the YouTube, as well as you will get the slides back. These questions are from that code only. I have just picked it up to see if you guys are attentive or not. If you guys get this answer as wrong, just refer to that code. Otherwise, there are many doubts. Just then go through YouTube videos, which will send the recording soon. Guys, vote fast. 1 minute more. I think maximum of you have hold your answers. I'll show you. Correct. This time 78% people like gave correct answers. So it's fine, but still the next 22% people refer to the slides as well as the YouTube recording, which we'll share soon. And another main thing is we'll soon share the next problem set, that is PS4 on sortings only, just within a few minutes. So attempt it as soon as you can. And if you have any doubts, then just post it in the group. Okay. Thank you, guys. Thank you so much.
Abhilash, show your QR code to them and ask them to rate the session.
Okay, just a minute. Just a minute. Guys, please rate this session as well. We get a very valuable feedback from you guys so that we can improve in next session too. I just rate it honestly. I know it was a pretty fast session, but still it's 6:42. Just waiting for your feedback. Aditya, I think it was sufficient time, I guess. That's it. Thank you guys. Thank you so much for this session.